Okay, so guys, now I'm gonna go back to ionic compounds. There's a little more that we need to learn here. So guys, when you talk about ionic compounds, you guys remember that ionic compounds are made up of metals and non-metals. I hope you will remember that after me repeating this so many times. Ionic compounds, metals, non-metals, and you guys know metals are two types, type 1 and type 2. Type 1 are fixed, and type 2 is not fixed. Can you guys tell me the examples that we did earlier, like this CaCl2, the one with the calcium, and the one with the sodium chloride, will you put them under type 1 or type 2? Again, you look at the metal. The question is sodium and calcium. Sodium and calcium. Sodium is sitting here. Calcium is sitting here. For both of them, we know the charge, so they are type 1. So both of these were example of type 1. Type 1 are the easiest one to name in ionic compounds. But we need to also learn type 2 compounds, type 2 ionic compounds. So guys, when it comes to type 2 ionic compounds, let me take an example of somebody who is a metal who is type 2. Which ones are type 2 metals, guys? These are type 2 metals, all of these here, for which we do not know the charge, except these exceptions that we learned. So I'm going to mark those out. So forget about these ones. But all these remaining ones, they are type 2 metals. So let me pick Fe. What does Fe stand for, guys? Fe stands for iron. Now, Fe we know. So for example, for a type 2 is Fe for instance. So guys, if I have Fe combined with chlorine, you have FeCl2. And now for Fe, there's another option. Fe can also do this, guys, FeCl3. Now, calcium, the previous example, calcium is always calcium chloride as CaCl2. CaCl3 is not possible. Why not? Because calcium will never be plus 3. Calcium is always plus 2. So this is the only possible formula for calcium to be with chlorine. But when it comes to Fe, since it's not a fixed charge, it can be plus 2. You guys can tell that, just like the CaCl2 formula. This 2, guys, came from the charge of Fe. So Fe must be plus 2 here. And when you see FeCl3, what does that mean? This 3 is coming from iron's charge. And Fe must be plus 3 here. So you can tell that Fe can be plus 2 and Fe can be plus 3. So you know it's not fixed charge, right? So now, your job is not that you have to remember that Fe can do plus 2 and plus 3. Your job is that if I give you this on the exam, FeCl2, you should be able to tell me the name for this. And if I give you the name, you should be able to give me the formula. So as you guys can tell, iron chloride can be found in two forms, FeCl2 and FeCl3. So we must have two different names for them. So what we need to do, guys, again, this is for type 2, okay? So remember that, for type 2 metals. We're still talking about ionic compounds, but type 2 metals. So how we name this case is, this thing is, Fe stands for iron, and Cl is chloride. So we're keeping that as it is. But you need to add a parentheses here, guys. Remember that. In type 2, you need to add a parentheses. Here also, guys, this guy will also be iron, parentheses, chloride. We need to put a number, guys, in this parentheses, and we'll learn what number to put here. So both of them are iron chloride, you can tell that, right? So let's say you're in a lab and you want to do an experiment in which you need FeCl2, you need FeCl2 and not FeCl3 in the lab. So when you're going to order the chemical, guys, let's say they're asking you from the name, tell us the name of the iron chloride that you're looking for. So we have to have a name that is going to distinguish FeCl2 from FeCl3. The number that you need to put here in the parentheses in both the cases is the charge of the metal. And who is the metal here? Iron. So put the charge of metal in the parentheses, and it has to be a Roman numeral. Okay, so when you look at FeCl2, guys, what is the charge of Fe? I already talked about that it should be plus 2, and this Fe should be plus 3. So we should be putting 2 here, and we should be putting a 3 here. Again, you cannot put the digit number like 1. You cannot put 1 or 2. You don't use that. Instead, you use the Roman characters. So 1, 2 for 2 lines for 2 and 3 lines for 3. If you have 4, you show it like that. If you have 5, you show it like that. If you have 6, you show it like that. If you have 7, you show it like that. Okay. All right. So this example, guys, was pretty simple in the sense that you looked at this number 2 and that told you that FE is plus 2. Here, you know FE is going to be plus 3, and we simply got the answer. Let's look at a more advanced question, okay? So when you take an example of, let's say, PBO. So PBO, guys, is PB. What does PB stand for? So PB is sitting right here. PB is lead, and O we know is oxygen. So guys, PBO, this guy is going to be lead. Now guys, tell me, do I need a parentheses here or no parentheses? So first of all, you ask yourself, what kind of compound is this? This is ionic compound because it's made up of a metal and non-metal. Then ask yourself, what type is it? Is it type 1 or type 2? So you go to lead. Lead is sitting here, and this is type 2, no fixed charge. Because again, if you're confused, how do you tell type 1, type 2? Go back to the lecture notes and see. This is where we learned what is type 1 and type 2. Okay. All right. So PBO, ionic compound, and it's type 2, so we do need parentheses. So lead parentheses oxide. But what goes in parentheses is the main question. So you look at PBO and you ask yourself, what is the charge of PB should be? Now, it's not as simple as just saying that PB is going to be up. Since you see 1 here, that PB is going to be plus 1. And you see PB is 1 here, so oxygen must be -1. That's not the case. So you have to be a little careful here. So whenever you see ionic compounds, and you could have done that to the previous examples we did here, like FeCl2 and FeCl3, what we should do always is, we should take our ionic, this is only for ionic compounds, guys. You don't need to do this for covalent compounds. You'll do this for ionic compounds, and you'll also do this for acids. So for ionic compounds, you cut your molecule into half. You go to the right-hand side first. Why not here? Because what we're going to do is we're going to write down the charges for these guys. For PB, do we know the charge? No, we don't know the charge. So I'm not going to start from left-hand side. I'm going to start from the right-hand side. So I'm going to look at the oxygen and ask, what is the charge of oxygen? Do I know the charge of oxygen? Let's look at the periodic table. This is oxygen. Do we know the charge of oxygen? Yes. We know it's -2. So oxygen is -2 charge. So guys, if right-hand side is -2, what do you think? Left-hand side is going to be how much charge? And remember, guys, PBO, who are sitting next to each other, they're sitting like this in a compound with a 0 charge on the top. What does that mean? That means that PB, whatever the charge of PB is, same charge is what the same magnitude of charge is what oxygen is going to have. Of course, PB is going to be plus, oxygen is going to be minus, but that's a different thing. What I'm trying to say is, if this is going to be -1, this must be +1. That's when their charges will cancel and you will get a 0 charge. Okay, so now the question is, if this thing is -2, then what do you think the charge of this side is going to be? If you guys can tell, it should be a +2 charge. Because if you have a +2 charge and a -2 charge, you know these total to a 0. And that's why PBO does not have any charge here. When you don't see any number, that means there's no charge, okay? Later on, you're going to see examples where SO4 has a -2 charge. So that's a different thing. We're not going to go there right now. We're going to come back to that later. So PBO, if we figured out the charge, we start from the right-hand side first. Oxygen is -2 charge from the periodic table. So if this guy is -2, this must be +2. So guys, what do we put here? We put the charge of the metal, which of course is always positive. So charge of the metal. So that's why you never say plus or minus. We know it's going to be positive. So charge of the metal is 2. How do I write 2? Can I just put 2 like that? No, that's going to be incorrect. What you need to do is you need to use this symbol for 2. So that is lead 2 oxide. So that's going to be your answer. Okay. So if I ask you on the exam, what is the name of PBO? Lead 2 oxide is the name of PBO. So this is the formula. And this is the name. Now guys, if you're having a hard time understanding this, please go back to this video, go back from the beginning and watch the video again, or any part that you're not understanding, guys, watch this again and again, and this will make sense. Nomenclature is a big topic and it's a complex topic. So you do need a lot of practice on this, guys. And again, I'll suggest you, after you do this lecture, study exercise C, and that's going to be very helpful for you learning nomenclature. Now, talking about the next type of compound case, we're going to talk about covalent compounds. So if I remind you where we were, so we learned that we have 3 different types of compounds. We have ionic compounds, covalent or molecular, and acids. We just covered ionic compounds. In ionic compounds, we learned they're made up of metal and nonmetals. Since metals are 2 types, our ionic compounds are 2 types, type 1 and type 2. When they are type 1, for example, you have calcium chloride, you just write, so for CaCO2, the name is just calcium chloride. When you have NaCl, its name is sodium chloride, not sodium parentheses chloride, not calcium parentheses chloride, because these were type 1. So guys, if I want to summarize that here, type 1 don't use parentheses, whereas for type 2, you use the parentheses, okay, for the metal.